Well, welcome to this online revision session for AQA FP2. In this session we'll be covering the June 2011 question 2, which covered the topic of hyperbolic functions. As you can see, there are two parts to this question. In the first part we have to show using the definitions of sine and cosh, which remember are in the formula booklet if you forget them. Okay, that this identity is true. And then in the second part, split into two parts, we have an equation involving cosh and sine that we have to solve, expressing the answer to it in the form of tan x equals 5/7, and then in the second part solving that, in other words rewriting it as x equals tan to the minus 1 of 5/7 and using the log form of tan to the minus 1, which again is given in the formula booklet. So it's quite an involved question. So let's see how we get on with this. So this first part, we've got to show that this is true. So generally speaking, I think it would be easier with this one to start with the left hand side, and then using the definitions of cosh and sine, simplify the expression and hopefully come up with the expression for cosh of x minus y. So the left hand side then will become, well, our definition of cosh is e to the x plus e to the minus x over 2, and that's multiplied by e to the y plus e to the minus y over 2, and then from that we have to subtract the sine, which is e to the x minus e to the minus x over 2, and that's multiplied by e to the y minus e to the minus y over 2. Well, we can see everything will be over 4, so we can take the quarter out the front. And then what do we get? Well, we're going to get a whole collection of terms. So we've got e to the x times e to the y plus e to the minus x times e to the y plus e to the x times e to the minus y, and then the last term from the first pair of brackets will be e to the minus x e to the minus y. And then from that we're then going to subtract e to the x times e to the y, and then we would subtract, but it's going to be e to the minus x e to the y, and there's two negatives will result in that being plus e to the minus x e to the y, and then similarly we're going to have plus e to the x times e to the minus y, and then the last term will be minus e to the minus x e to the minus y. And looking along that, there's a few terms will disappear, like the e to the x e to the y with the minus e to the x e to the y, and then the e to the minus x e to the minus y goes out with that one. So we're left with two lots of e to the x e to the minus y and two lots of e to the minus x e to the y. So if we take the factor of 2 out, that then will become a half of e to the x e to the minus y, and plus e to the minus x e to the y. And of course that can then be written as we can add the powers of the x and the minus y together, so this then becomes e to the x minus y, and then this would be next term that we're adding becomes e to the minus x plus y, but we can rewrite that as minus x minus y. So this then is in the form of the cosh function, because remember cosh is e to the something plus e to the minus something, and the something in this case is x minus y. So this becomes what we require, which is the cosh of x minus y. Okay, a little bit messy. Let's see what we're going to get the marks for. Well, 1 for getting this opening statement, applying the definitions of cosh and shine, you'll get a method mark, and then an accuracy mark for getting the correct statement. To then get a correct expansion, you will then get 1 mark, and then simplifying it down to the correct form for the cosh x minus y, you'll get another mark. So that will give you your 4 marks for that first part of the question. Okay, so in the next part we're now being asked to solve the equation cosh x minus ln2 equals shine x. Well, what did we do in the first part? Well, we had showed that cosh of x minus y could be rewritten as cosh x cosh y minus shine x shine y. So we can apply that identity to the left hand side of this. So if we do that, that is going to start us off, because we're going to have then cosh x cosh ln2 minus shine x shine ln2 equals shine x. Now cosh of ln2 we can actually work out, because we know that the cosh of ln2, cosh is e to the x plus e to the minus x over 2. So if we do that, what are we going to get? We're going to get cosh of ln2 is going to be e to the ln2 plus e to the minus ln2 over 2. Well, e to the ln2 will be 2, because the e function and the log function are inverses. E to the minus ln2 is the reciprocal of that, which is going to be a half, so that's 2 plus a half, so that's 2.5, or 5 over 2, and that's divided by 2 again, so that becomes 5 over 4. Similarly, for the shine of ln2, that will become the same thing, except that we've got to subtract and divide. So it's going to become 2 minus a half, so that'll give you 3 over 2 divided by 2, so that makes that value 3 over 4. So we can substitute those back into our equation. So that gives us 5 over 4 lots of cosh x minus 3 over 4 sine x equals sine x. So if we take the add 3/4 of sine x to both sides, that is going to give us 5 over 4 cosh x equals 7 over 4 sine x. Now the answer we were trying to get was for than x. Well, we know that than is sine divided by cosh, so if we divide both sides by cosh, that will give us than x, and if we divide both sides by 7, because the 4's will cancel, that will give us 5 over 7 equals than x as required. Well, 4 marks there will be 1 for using an appropriate substitution. For obtaining these values for sine and cosh, you'll get a mark for those statements. You will then get an accuracy mark for obtaining the 5 over 4 cosh and the sine, and then for rearranging that to get the final answer. Okay, so there's the 4 marks for that part. And then finally into part 2, to get x, we know then that x will be equal to than to the minus 1 of 5 over 7. And if we look up the than, we know that it's equal to, from the formula booklet, a half ln of 1 plus x, so that's 1 plus 5 over 7, over 1 minus 5 over 7, which is going to give us a half of, well, that's going to be 7 over 7 plus 5 over 7 is 12 over 7 over 7 minus 5 is 2 over 7, and 12 over 2 is going to give you 6. Okay, so again, 1 for showing an appropriate method here, and then obviously an accuracy mark of 1 for getting the right answer. And that will complete that question. Well, hopefully you found that solution helpful. For further support, please go to the Further Maths Support Programme website.